welcome to another edition of ARC Advisory Group's Digital Transformation Podcast. My name is Bob Gill, ARC General Manager for the Southeast Asia region. And today I'm delighted to have with me someone I've known for more than 20 years here in Singapore, and he is Mr. Jonas Berge, Senior Director, Applied Technology at Emerson Automation Solutions. So a very warm welcome to you, Jonas, and thank you for being here today.
My pleasure, Bob. Thanks for the opportunity to speak about how we help plants with digital transformation.
Okay, great. I'm really looking forward to this conversation. I see from your LinkedIn profile, Jonas, that you have over 30 years of experience in instrumentation and controls. And indeed, if I can say, you have been fully immersed in the automation industry as the author of books, patents, numerous articles, frequent conference presentations, work on standards committees, etc. So it seems perhaps that this is more than just a day job for you. So what drives your enthusiasm for automation, or more specifically, process automation?
Well, Bob, what gets me out of bed each morning is that automation. We are helping plants to do something very important. Automation is the enabler for all industrial revolutions. Currently, we are at the fourth industrial revolution, but also in the earlier ones. We enable plants to produce an abundance of food or beverage, clean water, clothes, building materials, energy, light and power, hygiene products, medication and other daily necessities, and fuel for transportation, all in a sustainable fashion. That's what drives the passion. I think we should celebrate automation engineers. Yeah.
Yeah, I think that's a very, very good idea. And I know you've had a number of different job roles in that time, but now your current role at Emerson as Senior Director of Applied Technology, what exactly does this involve?
Well, for every new industrial revolution, there is a new automation brought forward by the application of new technology. Like in the first revolution, it was steam engine governor. In the second industrial revolution, we had pneumatics. In the third industrial revolution, we had analog electronics. And now in this fourth industrial revolution, we are going all digital. So my job is to help plants cut through the hype and get them started on their digital journey. And this starts with a discovery workshop to cover challenges the plant is facing. And we also explore the many new digital solutions for this, such as dashboards and augmented reality, the underlying predictive analytics and the data management and advanced sensors. If this is conducted in our solutions center here in Singapore, I let plant personnel try all of this hands-on, including virtual reality and wearable tablets, etc. And then in the next stage, we map the challenges to ready-made solutions, and we also co-create new solutions if needed. I should say we have solution centers in other countries as well.
All right, okay, that sounds interesting. And I know that over the years, the two of us have had many discussions on topics like field bus, device management, EDDL, wireless instruments, and more recently, digital transformation. But how important are those earlier technology developments in providing a foundation for what everyone is talking about now, which is digital transformation?
Well, indeed it is. Digital transformation means changing from manual and paper-based ways of working to new automatic digital software-based and data-driven work practices. This means plant personnel have a personalized dashboard with information and mobile notifications relevant to their work. The information on the dashboard comes from analytics. The analytics uses data, which in turn comes from sensors. Plants already have lots of sensors, but those are process sensors. You can't predict equipment problem using only process data. You also need equipment data. So you need additional sensors for, well, vibration, acoustic noise, corrosion, temperature, and fluid levels, etc., sitting on your pumps and heat exchangers and so on. Well, it's not practical to wire all of these additional sensors in a running plant. Therefore, wireless sensors are critical to digital transformation, and device management is a good tool to manage the health of all of these sensors themselves and the valves.
Right. Okay. So you're saying that this has been like a natural evolution to where we are now on the cusp of digital transformation. We needed those earlier technologies to be in place.
Absolutely. I think people loved what we did, with diagnostics on valves and sensors, etc. But customers also told us in no uncertain terms that they actually have bigger problems. And those are the pumps and the heat exchangers and the cooling towers, bigger assets, bigger problems, right? So they asked us, to take that same philosophy and apply it to these bigger assets, and that's when we realized that, yeah, we need, with so many sensors, you can't do point-to-point wiring. You need to have that digital networking of all of these sensors. Yeah.
Right. And you mentioned just now that you spend quite a bit of time with customers. So as you go around Asia talking about how plants can embark on and benefit from digital transformation, I'm sure you must come up against misconceptions or misunderstandings about what this is all about. So perhaps you can tell us, what are some of the biggest misconceptions you come across? And the reason I want to ask you this, Jonas, is because there has been such a buzz about digital transformation over the last few years that I find that it's very easy for people to get confused amidst what is really an onslaught of information that they're really faced with. So what are some of the bigger misunderstandings that you come across?
Oh, there are several misconceptions. Yeah? Like, you need to hire a data science team, or you must merge the IT and OT teams, or sensors going to cost $10. You need a single data lake for both IT and OT data together, or ready-made software won't fit. You need to custom program or custom code something. Yeah, you need to convert to MQTT to send data to the cloud, or you need a PaaS cloud platform, or there is no Purdue model anymore. The architecture is flattened, or there is too much data, that sort of thing. And in addition to those misconceptions, there is an overemphasis on putting everything on a single platform, forgetting about the IEC 62443 security zones. And there's an overemphasis on using historical data, big data. There's a overemphasis on IT perhaps, and a tendency to overprescribe machine learning, even for use cases where rule-based AI would actually do better. And there is a tendency to prescribe building of a digital twin for solutions, including analytics, historian, and document management, which is not a digital twin and does not require a digital twin to be built. In reality, what you really need is, and I trust it's okay for me to make a couple of recommendations here, Bob, real quick, okay? First,
yes, sure.
The right purpose-built analytics software can be used by your existing maintenance and reliability engineers. They don't have to become data scientists. Second, IT and OT teams can remain in their existing departments and still collaborate on projects. Third, advanced sensors, which are wireless and non-intrusive, are not as cheap as chips. Instead, think total installed cost and total cost of ownership over the entire life cycle. And keep the OT data lake independent of the IT data lake. Yeah. The most interesting fact is that there are ready-made apps with proven track records for most use cases in plants. You can just buy and use for analytics. Yeah. And OPC UA, Hard IP, Modbus TCP can all go straight to the cloud if need be. Another one, on-premises or edge computing is often best, or use IaaS or SaaS model if you really want to go for cloud computing. Use a layered architecture like the Purdue model for defense in depth. Sense every part of the plant. Yeah. Design your systems around the Namur open architecture with monitoring and optimization independent of the core process control. To be predictive, you need real-time data, so you need more sensors. Digital transformation is plant automation, right? So the INC team in the plant must take the lead in digital transformation. Use rule-based AI for a piece of equipment or unit process analytics, right? And machine learning for the complex composites of many pieces of equipment and the end-to-end process. A digital twin is used for simulation like operator training, simulator, or virtual reality. It doesn't have to be built for analytics or storing data or storing documents, to name a few.
Okay, Jonas. So I see here you listed quite a number of misconceptions. Out in the market. Do you know why these have arisen so much? Is it that people are being hit by all sorts of stories from suppliers or from conferences they attend? Why have these misconceptions arisen to such an extent?
Oh, yeah, that's a good question. Of course, suppliers, promote their technology. And I guess if a supplier only has one technology, they will tend to push that technology for all applications, right? If all you have is a hammer, everything looks like a nail, So I think that could be one reason. I think another reason is that we have seen success of certain technologies like data science, machine learning form of AI has been tremendously successful, I guess, in detecting credit card frauds and predicting if people are going to default on their loans and a number of other applications, right, which are really advanced. And so the thought then perhaps becomes that, well, then it can probably be used for everything in a plant as well, but that's not quite the case. Certainly there are lots of applications for machine learning in a form of AI in a plant, but it's not always the best solutions.
Right. And I think you have been quite vocal over the last couple of years in emphasizing that AI-based analytics is not always needed or appropriate. So if you can clarify for our audience, then what else should they be looking at?
Okay, so let me clarify that a little. So AI is the right answer, but there are two branches of AI. The first one is, there is rule-based AI, and then there is machine learning AI. There has been an overemphasis on that data science, machine learning branch of AI, which might be only 20% of use cases in a plant. While the engineered rule-based branch of AI is perhaps 80% of the use cases in the plant. For instance, rule-based AI is easier to use and more robust for use cases like a single piece of equipment, like a compressor or a unit process, because the first principles and models are already well understood from physics, chemistry, and mechanics. So no algorithm training is required, very easy. So instead, use machine learning for the machine learning branch of AI for composites of many machines and the end-to-end process where there's complex interaction. This is where you analyze historical big data to build or train a model, to kind of create knowledge where there is no knowledge, right? So this model is then used with real-time data for prediction. And third, deep learning, AI, is the next level for image and voice recognition, etc. Anyway, Emerson's Plant Web Insight application framework is purely rule-based, covering most use cases in the plant, while our Plant Web Optics analytics framework supports both rule-based and machine learning in the same software. So you can select the right type of AI for each use case.
If we just zoom out for a little while, so one of the things that we advocate at ARC is that digital transformation should proceed in a logical, structured manner, and companies should avoid just throwing in technology and hope some of it sticks and has the desired impact. With that in mind, I know that earlier this month, in March, Emerson announced the launch of what is called the Digital Maturity Quick Index. So perhaps can you give us some details about this and its relation to Emerson's digital transformation roadmap, which I believe was from a couple of years earlier?
Yeah, I agree. It's not technology for technology's sake, right? So how does a plant justify to their executives that they need to digitally transform? And where are changes needed? So this is an online self-assessment tool that helps to rank your plant on a scale from conventional manual all the way to digital, and compares against the industry average, your peers. And it does this by domain, such as reliability and maintenance, energy and sustainability, safety and production, etc. With this report, you can then get leadership approval for exploring digital transformation in depth. So with that, you can now organize workshop to capture plant problems, and followed by mapping to solutions and the right technologies.
Okay, so I think you mentioned at the start about a little bit about how you engage with customers. So when you go into a typical plant environment, talk about digital transformation, what are the first things that you do in terms of kicking off that conversation?
You start asking people, how is your plant running? Well, then they'll say, oh, it's fine, it's okay, and then you have to probe a little. So you have to ask, well, do you have pumps in your plant? And they'll say, of course we have pumps. All plants have pumps, right? We've got hundreds. It's like, oh, so do those pumps fail? Well, of course they fail. They are rotating equipment, of course they fail. So then, you see, you have problems, So yeah, you will have to kind of open up the conversation that way, a little bit of probing questions, okay? And the way we do it, it is by domain in the workshop, and it has to be kind of open, because in understanding that we're not there to find faults or rank them as bad. We're really there to uncover challenges and help solving them. And and you can also show the art of the possible. What are the technologies out there? What are the plants doing? Then little by little, people open up, and we can have a very productive session, uncovering challenges across all domains, that we can then subsequently find solutions for.
Okay, and these workshops, would they be day-long or multi-day events?
Well, there are all kinds. They can be up to 2 days, sometimes they can in fact be as short as half a day, Best is if you get all of the departments represented, right? Because you want maintenance and reliability, integrity, process, energy, production and quality and whatnot, you need to have them all represented, And the way we do it, okay, is not really the old school, post-it notes and flip charts. We have actually digitalized the digital transformation workshop, right? You got to walk the talk, right? So actually, people use their smartphone, or they use, if they're in the solution center, they use the tablet that we lend to them, and that kind of actually speeds up the data collection and the tallying of the results, So the kind of workshop can be done pretty quick,
Yeah. So you mentioned the solution center a couple of times now, Jonas. So for people, particularly those outside of Singapore, who may not be so familiar with this facility, perhaps you can let us know a little bit more about that.
Well, Okay, so first of all, I'd just like to take the opportunity to say that we also have solutions, in other places in Asia. We have them in Manila, in Seoul, and a few in China, like Shanghai and Beijing. When we started talking about digital transformation, we came to the conclusion that just showing PowerPoint is too abstract, and so we decided to build, well, first a little small lifelike plant, and when people come, we start off in the boardroom, and a very short introduction, but then we start taking it from the top. We look at, what are dashboards? What do dashboard looks like, and how does having information at your fingertips, getting notification on your mobile, how does that change the way you work in the plant? Okay. And after that, well, then we move on and we look at, what is the underlying software that allows this dashboards, where does the information come from? That's the analytics software that generates the, not only the KPIs, which tend to be lagging, but the more predictive, leading real-time indexes that need to drive your work, So we look at all the kinds of equipment performance analytics, equipment condition analytics, process analytics, location analytics, batch analytics, all the different kinds of energy management information system, all of the different software apps that is needed to provide the information that allows you to go data driven. And then lastly, well, then we go and take a look at the underlying sensors, right? Because, plants, yeah, they do have thousands of sensors already, but those are process sensors, They also need to have equipment sensors so they can automate other data collections, the operator. So there's no more operator rounds, looking at mechanical gauges or using portable testers, that will instead be done by permanently installed sensors, to make you more predictive. Okay, and people get a chance to carry these tablets, to take photos of leaks, to report that, use wearable camera, to guide a remote technician in the field. Use augmented reality to locate assets, diagnose assets, equipment. Install non-intrusive sensors, so they can feel for themselves that these sensors simply clamp onto the outside of the pipe or the outside of the vessel. There's no cutting, there's no drilling, there's no welding, So, you can say all of this in a PowerPoint or in a podcast, but nothing beats really coming there and actually doing it, So do come and visit our solution centers. Yeah.
Okay, sounds. I've been lucky enough to visit myself, and I would certainly recommend taking a trip down there if you get the chance. Technology is certainly important, and really plants cannot digitally transform without deploying technology. So let's talk a little bit about Emerson's Plant Web digital ecosystem, which I see won an Edison Award for innovation last year. So I think the Plant Web brand has been around for quite a long time, and people would probably recognize that. But the Plant Web digital ecosystem, Jonas, what is that all about?
Well, it ties in a little bit with what I said earlier. Okay, but really, there's a whole stack of technologies required to digitally transform a plant. So looking at the technology stack from the top, right? So first, at the top, there's the user interface, the web-based dashboards, the mobile notifications that display the real-time information that allows each person to do their work better. This information comes from the analytics apps in the analytics framework, which is the layer below that. This includes, the equipment condition, performance analytics, energy management, process and batch analytics, location analytics, etc. The analytics in turn runs on data which is aggregated in the OT data lake, from multiple sources, including existing systems such as your DCS and Historian. The lowest layer, the foundation, if you will, is the additional permanent sensors to automate manual data collection. No more operator rounds for reading gauges or maintenance inspection with portable testers. So those are the 4 layers in the technology stacks. Now, plants don't want to put all of that together themselves. Plants also don't want this to be put together for them by somebody else for the first time either, because custom solutions require lengthy proof of concept pilots. Plants ask for proven track record. So that's why we designed this ecosystem of Plant Web Insight and Plant Web Optics Analytics, Plant Web Optics Data Lake, and the suite of wireless sensors. And that's what we call the Plant Web digital ecosystem. So not just sold together, but designed together to make the most of digital transformation. Yet, Plant Web is built on open standards such as HTML5, Wireless HART, OPC UA, and HART IP, etc. So third-party components such as the plant's existing systems also fit.
Okay, thank you. All this obviously needs to have an impact to the customer. So perhaps you can tell us a bit about specific digital transformation projects here in Southeast Asia or the wider Asia region that you've been involved in last couple of years that can illustrate, the use and benefits of Emerson's approach and Emerson's technology?
Well, there are many good examples. Okay. One that comes to mind is one of the refineries we worked on here in Singapore. They embarked on digital transformation some years ago to tackle common refinery pains. They are thinking big with a vision of standards-based, plant-wide digital infrastructure like Wireless HART, to enable new digital ways of working. Yet starting small, deploying software and sensors for a few use cases in part of the plant, ensuring quick success. In short agile sprints before scaling fast of the infrastructure and solution to the rest of the plant. Then solving new use cases for holistic transformation. And they have transformed, ship loading, oil spill and slop monitoring, steam trap and relief valve inspection, pump condition monitoring and corrosion monitoring, etc. And recently, they also added Wi-Fi networks in the refinery. So, and operational results already proven include, greater safety. They have become more environmentally friendly, more productive, greater energy efficiency and sustainability, greater asset availability, reduced maintenance and other costs. And it proved valuable during, the COVID lockdown.
So it proved valuable for what reason?
Well, with social distancing, right? It's difficult to have a lot of people in the plant, right? And plants also rely very much, because even though the core process control is fully automated, many of the auxiliary functions, like maintenance and reliability, rely on very manual data collection. So there's a lot of plant personnel actually collecting data, and external contractors also collecting data, so with social distancing, that became a problem, right? But, once you have these sensors in place, the plants that have sensors in place, they are less reliant on having large number of people running in the plant, so it becomes a matter of business continuity there.
But if we perhaps look forward 10 years or so to 2030 or into the next decade, do you have a vision of what the process plant will look like come 2030 or beyond?
Yeah, well, I think the energy transition is going to be a big driver for innovation in automation, right? So energy sources increasingly include like solar and renewable, used to produce hydrogen or ammonia, which are transportable, right? And I think this will happen in many small modular plants, near the remote energy sources. To be practical, such small plants should be largely autonomous, managed centrally from a regional or global fleet management center. So, and sites visited only on rare exception, really. Emerson is well positioned to help power plants and energy companies with this, with the Ovation OCC 100 and Delta V PK controllers, grid management software, and support for the Namur module type package or MTP, the plant web digital ecosystem support for the Namur open architecture or NOAA. OPC UA is a key technology in these approaches, supported in many Emerson systems. Mm-hmm. Another technology to watch for any industry, which is not here yet, is Ethernet APL. That is two-wire Ethernet with intrinsically safe power. So APL will make it easy to run Ethernet all the way into the plant process areas. So I personally see APL not only taking the place of 4 to 20 milliamp and on-off signals in the field instrumentation, but also as like a single infrastructure, also taking the place of video signals, RS-485 and regular Ethernet too, in all kinds of devices that you find in the process areas. Just like Ethernet is also taking the place of phones and CCTV in the office. So we will see new innovative instrumentation with the APL, but also some, video cameras, IR cameras, HMI panels, LIDAR maybe, sharing that same network. And Emerson is well positioned here too, with pioneering work on Hard IP.
I'd like to thank you for your time today, Jonas, and for telling us all about digital transformation, the approaches, the technologies, and the way forward for plants, and how plants are already benefiting from new digital ways of working.
And again, thanks for the opportunity to speak about how we help plants succeed with digital transformation.
Okay, thank you, Jonas. And we have been speaking to Jonas Berge, Senior Director, Applied Technology, Emerson Automation Solutions. Do look out for future episodes of ARC Advisory Group's Digital Transformation podcast. And goodbye, and see you next time. Thank you.